Welcome. My name is Edgar Magallan, and in this work, we talk about the synthesis of this solid solution for photocatalytic hydrogen production. Has an introduction rising energy consumption, driven primarily by fossil fuels, is aggravating the problem of global warming by increasing greenhouse gas emissions. Hydrogen, with its high energy density, is presented as a promising alternative to fossil fuels. This work proposed the production of hydrogen through the photoreforming of alcohols using a solid solution as a photocatalyst. This solid solution was synthesized via ultrasound-assisted Solgel method to investigate the impact of different cation concentration of the material physicochemical properties and its photocatalytic hydrogen production efficiency from alcohol photoreforming. In the methodology, stoichiometric calculations of precursors were performed, and the Solgel solution was formed by stirring. Then it was passed to ultrasound for 2 hours for the formation of the gel. Then dried and calcined at 700 degrees Celsius to form our photocatalyst. As a resultant discussions, we compare all the samples with the hexatitanate of potassium card, and as a control sample, we use a solid solution with zirconium. Use it in a previous work. In the X-ray analysis, all the samples show defined signals indicating high crystallinity. Zooming around area 10 and 15, when the zirconium is added, a shift to the left is observed, and when the sodium is added, a shift to the right is observed. This is caused by the size of both cations. UV-vis analysis shows that all samples exhibited maximum photoabsorption in the UV region. This value remained constant in solid solution with added sodium, but increased when potassium was entirely replaced by the sodium. Through the chalk plot analysis, a decreasing band gap was observed for most samples except for this solid solution, which showed an increase the band gap. Rietveld refinement showed a decrease of the cell volume, axis A and axis C. On the other hand, the size crystallite general tendency of increase in size can be observed as a sodium is added. The hydrogen production rate was obtained for all the samples under UV radiation and 20% methanol solution. This solid solution with 0.5 sodium obtained the highest performance. This sample exhibited cell parameters outside the trend, with a larger cell size and increase in the axis. So we can infer that it's present a greater amount of crystal defects. As a conclusion, the solid solution was successfully synthesized. The X-ray shows a distortion of the cells by the incorporation of zirconium and sodium. With increasing sodium concentration, a general decrease in cell volume and A and C axis will be observed, generated by the introduction of a smaller cations. A 28.5% enhancement in hydrogen production rate was observed for the best samples with 0.5 sodium, compared to the solid solution with only zirconium. This improvement could be attributed to the increased crystal defects in the material upon substituting potassium atoms with sodium, which act as an electron trap that enhance charge separations. This is a reference that we use to this work. And finally, we would like to thank CONACYT for their financial support and the Department of Ecomateriales y Energía for their guidance and all the doctors who contributed to this work. We also express our gratitude to International Materials Research Congress for the opportunity to present our research. Thanks.